Today we're using deductive reasoning, a little different than inductive reasoning, where inductive reasoning you start with an observation and you move your way to a conclusion, okay, or a theory. Okay. Deductive reasoning starts with a theory and it moves your way down to an observation. So it's kind of going the opposite direction than inductive, and that's really all I'm going to go into that. I don't know that that's terribly important for what we're doing, but we're going to make a bunch of observations and try to draw some conclusions from those observations today. All right, so the first thing you need to do, though, is you need to get a textbook, define deductive reasoning the best you can. I'm not so concerned that you define the deductive reasoning all that much, but vertical angles, adjacent, complementary, and supplementary, use pictures to help yourself define those. So we talked a little about deductive reasoning, but vertical angles, you're going to see that a lot this year. Vertical angles, when we're looking at those, anytime two line segments or lines cross, they intersect. They intersect so that you have different portions, or four different angles. You have angle 1 and angle 2. Those two angles are congruent. The angles directly across from each other. We call them vertical angles. Okay? So in this case, angle 1 would be congruent to angle 2. You're going to use that a lot this year. Right? And then you'd have the same thing with these two angles. Maybe we call this one angle 3, just because we're non-creative like that, and angle 4. All right, notice we use two arcs there. Okay, so in this case, angle 3 is congruent to angle 4. Because we have those two arcs, that means they're not congruent to the angles with one arc. Okay? All right. Vertical angles there. Any questions on vertical angles? Using the same diagram, there are adjacent angles. Adjacent angles are angles that share a common ray or a common leg. So angles right next to each other. They're like neighbors. All right? So angle what and what are adjacent here? Go ahead, Grace. 3 and 2 are adjacent. So angle 3 is adjacent to angle 2. All right? They're adjacent. They share a ray. Okay? Angle 4 and 2, angle 1 and 4, angle 1 and 3. In this case, these adjacent angles happen to make up a straight line. So if I look at this angle, angle 3, and angle 2, they make up this straight line. What's unique about a straight line is that a straight line makes up 180 degrees. Once again, you'll see that a lot this year. So this whole angle right here is 180 degrees. You'll notice it's half of a circle. It's a semicircle. Okay? Supplementary angles are angles that add up to 180 degrees. So if I want to move that over there, I could say supplementary angles have a sum of 180 degrees. Now, how many angles do you need to make supplementary angles? How many angles must you have? 2? Could you have 3? Could 3 angles make up supplementary? Yeah, usually we see 2, but it could be 3. It could be 100 angles make up supplementary angles. Okay? It just so happens we don't show that many all the time. When you're making up supplementary or complementary angles, you could be using 4 angles to make that up. Think about supplementary, 180 degrees. You could have a 60-degree angle, a 59-degree angle, and a 61-degree angle. That makes up 180. 60 plus 59 plus 61 is 180. Okay, you could have 6 30-degree angles and make up 180 degrees. You can have a 150-degree angle and a 10-degree angle and a 20-degree angle. And that makes up 180 degrees. Okay, so it doesn't only have to be 2. A lot of times it is only 2, but it doesn't have to be. One way I like to remember supplementary and complementary, Well, let's talk about complementary first. Complementary does what? How many degrees in a complementary? Go ahead, Madison. Yeah, complementary. Complementary angles have a sum of 90 degrees. Now watch the magic here. Supplementary makes 180. What number is that? An 8. Complementary makes 90. What number is that? 90. Yeah, 9, man. 90 right there. Okay, 8, 180, 90. Okay. You may not think that's a big deal until you take your test this week and I have 9 definitions you have to do. And 2 of them are supplementary and complementary. Be like, dude, I hope I remember that. Okay, pictures help with definitions, right? Supplementary, I might just draw a picture of 2 angles that add up to 180 degrees and say, hey, this angle and this angle have a sum of 180. Vertical angles, I might just draw this diagram and say angle 1 is vertical of angle 2. They're congruent. They're vertical angles. Okay? Any questions there? All right. And the next thing we're going to do, we're going to go through the properties of equality in real numbers, and I'm just going to talk about those real quick with you. All right? Most of you have seen them before, so you know them. But just so you know, there they are. The addition property, this is on page 46 if you need it. You don't have to copy it all down unless it's something that you need to copy down. But addition property says if A equals B, then if I add the same thing to both sides, if I add C to A and C to B, then A plus C would equal B plus C. In other words, just like you've done in algebra for the last, when you've been dealing with algebra and when you're in 8th grade, 7th grade math, you're adding things to both sides of an equation to make it equal. How many remember doing that? You like have x plus 7 equals 5. Actually, I'm doing the subtraction property here, but same difference. Get it? Difference, subtraction. Pretty good. Okay, you subtract 7 from both sides. All right, that's all you're doing here with the subtraction property. If you're saying this piece, A, equals B, then if you subtract the same amount from both sides, they're still equal. So you've been doing that for years. Same thing with multiplication and division. Substitution, if A equals B, then B can replace A in any expression. You've done that with algebra. And then the distributive property. So all of these properties you've used all throughout algebra, you're going to still use in geometry. It's just expected that you know. Okay? All right, some of you look pretty excited, so we're going to move on. Properties of congruence. Reflexive property. You're going to use this a lot when we do proofs. Now, we'll actually ignore this for a while because we won't use it for quite a while, but later on in the year, I'm going to say, hey, that's a reflexive property. You're like, AB is congruent to AB. In other words, a line is congruent to itself. And some of you go, yeah, duh. I mean, it's like saying, hey, my finger is congruent to my finger because they're the same thing. Okay? That's what you're doing in reflexive property. We use that a lot in proofs. Sometimes some of the stuff we use is kind of like duh statements. Symmetric property, if AB equals CD or is congruent to CD, then CD is congruent to AB. Notice they just split them around. If angle A is congruent to B, then B is congruent to A. Intransitive, if AB is congruent to CD and CD is congruent to EF, then AB also has to be congruent to EF. Okay, it's kind of like a substitution thing here, right? If we know this is congruent to that, and that equals EF, then this has to equal EF as well. And that's what you're doing here. If A is congruent to B, B is congruent to C, then A has to be congruent to C. Okay, now that I've introduced those and just kind of pointed them out, and they're there, we won't use them for quite some time. The ones we're going to use today a lot, vertical angles are congruent. That's the vertical angles theorem. If you define vertical angles, then you don't have to copy down this theorem. And please note something about theorems. Theorem 1-1 in our geometry book is not the same necessarily as Theorem 1-1 in Snohomish's geometry book. So when you're using theorems, you can't go, yeah, I know that because of theorem 1-1. Or if you go home tonight and you're like, man, I got to memorize these. Okay, theorem 1 is, and you put them on note cards and okay, don't do that. You don't have to do that. Theorem 1-1 is unique to our book. Now this name is a mathematical term. If you went up to someone and said, hey, the vertical angles theorem, because it has a name, that name would mean something to another mathematician somewhere else or another student maybe in another school district. But this theorem wouldn't. The number wouldn't. Vertical angles theorem just says what we talked about earlier about vertical angles being congruent. That's all we're doing there. That's the vertical angles theorem. Congruent supplements. If two angles are supplements of congruent angles, or the same angle, then the two angles are congruent. We'll talk about that one when we do start our assignment. And congruent complements, if two angles are complements of congruent angles or the same angles, then the two angles are congruent. So this just says, if I know that actually let's call this A, let's call that B. Okay. If I know that A and B, what type of angles are those? Go ahead. Yeah? Yeah, they're supplementary. Everyone tell your neighbor why they're supplementary.
180 degrees.
Okay, volunteer, why are they supplementary? Logan. How do we know the sum's 180? As Julian pointed out, they make a straight line. They are 180. Very good. They're supplementary. We know it because they make a straight line. You need to get in the habit of seeing that. Anytime you see a straight line, you go like, hey, there's 180 degrees. Okay? For those of you like, I still don't get why that's 180. Here's a circle. There's a straight line. How many degrees in a circle?
360.
360. Half of a circle or half of 360 is?
180.
180. Okay? So, this is 180. If I say angle A and B are supplementary, and then I add another angle here, and let's call this one angle, I don't know, C. Just because I'm creative like that. And then I say other things like, I say something like angle C and angle B are supplementary. All right, what do we know? Go and talk with your neighbor. Based on those two statements, what's one other thing you can conclude about that?
C are congruent.
What else can I conclude? Carson?
A, B, and C are congruent.
A, B, and C are congruent. Can't say that. Something like that. Rory?
A and C are congruent.
Good. If C and B are supplementary and A and B are supplementary, then this has to be the same as that. Okay? Make sense? Angle A has to be congruent to angle C. And we had actually put the measure of that, but everyone get that? If this, someone give me an angle measure for B. Blake, give me an angle for B.
45.
No, let's go with something more realistic with obtuse.
110.
110. Okay, let's say this is 110 degrees. If that's 110 and this is a straight line, what does that have to be? 70. Okay, very good. That has to be 70. Okay, we know that B and A are supplementary. They have to add up to 180. We also know that C and B are supplementary. Well, if B is 110, what's C have to be? Hannah, what do you think? B is 110. What's C have to be?
70.
Has to be 70. Okay? Has to be 70 because they're supplementary, which means C and A are congruent because they're both 70. All right, I want you to apply the same idea right here for Theorem 1-3. You get 3 minutes to do it. Work with your groupie. All right, now I'll tell you guys, hey, I'm going to challenge you to think sometimes, and we just applied this, well, hopefully a lot of times, but sometimes out of your comfort zone. Okay, when I say try this, I want you to give it a shot. If you get stuck, raise your hand. I'll try to give you somewhere to maybe start a little to help out. Sometimes I'm going to tell you just struggle with it. But the first step here, if you're struggling, if two angles are complements of congruent angles. Well, first, I'm going to just start with if two angles are complements. Okay, so there we go. I have now made two angles. This is a right angle, meaning they add up to 90. If this is angle A and this is angle B, angle A plus angle B, so the measure of angle A plus the measure of angle B equals 90. Everyone agree? Yeah, right? Okay. So from there, that we have to it says if two angles are complements of congruent angles or of the same angles, then the two angles are congruent. Well, if I want to make another angle here, maybe I make angle, what are we going to call that angle?
C.
Oh, all right. Angle C. And angle C, the measure of angle C plus the measure of angle, which one? A equals
B.
so this angle plus this angle are going to add up to what?
90.
90. Okay. So what does that mean?
B and C are
It means this has to be equal to that, right? Because if A plus B equals 90 and C plus A equal 90, then these two pieces are the only parts that are different in those two equations. Those two have to be congruent. So measure of angle B has to be congruent to measure of angle C. Okay? All right. Any questions there? No, it's a bit different, a bit difficult. All right, I'm going to be handing out your assignment. While I'm doing that, I want you to look through this. Page 48 says you can draw certain conclusions directly from diagrams. You can conclude that the angles are vertical, that they're adjacent, that they're supplementary. But unless there are marks that give us information, you cannot assume. You're not allowed to assume things. You're not allowed to assume angles or segments are congruent unless you see the markings, even if the angles look the same. You can't assume that angles are right angles unless you see the markings. So for instance, when I look at letter B, is this a right angle?
Could be.
I can't assume it, right? I have to see a right angle marking to say it's a right angle. You can't assume lines are perpendicular or parallel. So based on that information, on letters A, B, and C, I want you to find at least one thing that you can conclude about each of those diagrams. Do that while I'm passing these out. So, angle or letter A, what can we conclude? Cameron, what do you got?
Angles 3 and 1 are supplementary.
Angles 3 and 1 are supplementary. How come? Someone else. All right, James, how come? How come these are supplementary? And how do you know that? Because they make a straight line. Very good. Guys, I need participation. If there isn't participation, I just got to call on you guys. Okay? Rory.
Angle 1 and angle 2 are congruent.
Angle 1 and 2 are congruent. Now, that's not really a conclusion. Well, I guess it kind of is. I mean, that's a marking, though. Angle 1 and 2 are congruent. Very good. Diamond. Angle 3 and 4 are congruent. How come? Good. So if these are the same, so for instance, let's pretend for a minute these are both 30. Hey, just so you know, if you're talking when I'm talking, it makes it distracting. Not to mention it distracts people around you, which is tough, even if you get it. So if these are both 30 and these are supplementary, that 30, that makes this 150. It would also make this 150 because that is. Now, we don't know that, but I'm just showing that those are congruent based upon how Diamond said it there. Anyone else there? Hey, very good. How about letter B? Hannah. Very good. Yeah, PQ is the bisector of TV. Chase.
Segment T is congruent to
segment TV is congruent to PQ. We don't know that. Yeah, we don't know that. We don't know that this one's bisected. And we don't know that these two are congruent. We do know something about this point right here. What is that? Haley?
Segment PW is congruent to
Segment PW is,
TW.
oh, TW. Yeah, to WV. Yep, by the markings there. Grace? There are vertical angles. These angles are vertical. Okay, so we can talk about congruence there. Jackson?
Segment TW is congruent to segment WB.
Good, that's what Haley just said. Yeah. What do we call point W? Yeah, it's called a midpoint by definition. It's the midpoint of TV because it cuts that line in half. Okay, how about letter C? Cameron, what do you got?
Angle WSZ and ZST equals 90.
Good, these two add up to 90. How come? Someone else. Go ahead.
Because WSR is 90 and 90 plus 90 is 180, and that's a straight line.
Good. Based on this right angle marking, we know that's 90, and that means this makes a straight line. So that means this has to be 90 over here. What else do we know? Diamond?
Angle WSC and ZST are
Good. We got those congruent markings. Chase?
They're supplementary angles.
These are supplementary, so we have three angles that are supplementary. RSW, WSZ, and ZST are supplementary. What else do we know? What do you know about these two? Other than them being congruent, what's the measure of this angle and this angle? Haley? Total 90. So what do they have to be? Yeah, they're going to be 45. Okay, because we have congruent, you have congruent complementary angles. Congruent complementary angles, the only way they can be congruent and complementary is if they're both 45. Chase?
So is Z the bisector?
Yep, Z is an angle bisector of WST. Nice job. So a lot of different things we can start concluding. That's what we're trying to do, is we're trying to start to see that stuff. Okay, so that helps us in our assignments. Let's take a look at your assignment real quick. Let's see if we can cut out the example side. In order to do that, I have to have full participation right here. So let's look at some of these. I want to try problem, to start with, I want to try number 1. Let's 1, 3, and 5. If I can get good participation there, you guys can convince me that we're good. We'll skip that. I want you to try 1, 3, and 5 right now with your groupies. Okay, I don't expect you to be done quite yet, but let's talk about 1 real quick. Just make sure we're all on the same page here. So AMC, so this big angle, is equal to 70. This is y, and this is 3y plus 10. That's our given. What can we do there to figure out the value of our variable y? Now, 1, need about 15 of these. So, yeah, good. Right. Hey, getting close there. Hannah, what do you think?
What if we do 3y plus 10 equals 70 and we solve for y that way?
We got 3y plus 10. So that's this angle right here, right? Okay. And then well, AMC. So what else are we going to have to add to that before we can get the 70? Yeah, plus the y. Plus that other angle, right? So plus this one. Add up to 70. Okay? Good. And then we solve from there, right? So we combine our like terms. We get 4y plus 10. Now when you guys are showing your work here, I just expect to see these steps like that. 4y plus 10. I know that 4y equals what? 60. You're subtracting 10 from both sides. I assume you can do that in your head. And then divide by 4, so 1y is? 15. That's the work I expect to see. 15 degrees. And you can always test it, right? 15, and then 3 times 15 is 45, plus 5 is 55. So 55 plus 15 is 70. Hey, that works out. Okay? Same idea here? Yeah? Yeah. Good. Same idea. What are we going to do on number 5? Number 5. Talk about it real quick. I didn't give everyone a chance to finish that one. So look at 5 real quick. Paid it yet today. You someone new? Maggie, I think you did, but go for it.
We're gonna do
Okay, so why are you setting these equal to each other?
Because the arrows show that they're congruent.
Okay.
I know.
So the arrows don't really show they're congruent, but what type of angles are they?
It's vertical.
Yeah, vertical, they make a V, right? Vertical angles. Okay, they're vertical angles. And vertical angles are? They're congruent. So we set that equal, and we solve, subtract 2x over to here, so we get x minus 3 equals 8, add 3 over, so x equals 11. And then testing it out, if I put 11 in here, that gives me 33 minus 3, or 29. Nope, 30, excuse me. Okay, and then 3 there, that gives me, or 11 there, that's 22 plus 8, which is also 30. So checked out, it works out. Any questions?